apart here some of the examples I have given. So I think what we have now to do, what we have, I think I will start, I think we do not need the outline because I want to stop within half an hour that we can start then with the examination. I think this one we have already had. You can remember, I brought this to your mind by showing the different connections, different links between the individual parts of quadrant 2, 1, 3, 4, 5. 4 is not included, but 5. What we will now do today and tomorrow in the morning will be that we will quantify the individual interrelations. Today we start with this one. Now what I now present to you will be the computation, how you can find, how you can compute the interrelation between final demand and production. And tomorrow we will make this one, and tomorrow we will make this one, and tomorrow we will make this one and this one. So all the individual connections will be shown to you, how it is necessary, what formula will be used, and what data, and what will be the result. So today, what I think is now my paper number 4, evaluation of interrelation between final demand and production as support of economic policy. You see again, I have for the third time, I reproduced again the basic IoT. We already know, but now in this table, what I have done a little bit better, I have here shown the separate parts of the table. You see here that is the total of the first part, here that is the total of the second part, because later on we need these totals for correction and for consistency checks. So for that reason I have here in this now, and here you see the final demand, you see the final demand itself, the total output, here the total input, here the, I think, the GDP, including the intermediate imports, here are the final imports are also shown, here are taxes for subsidies, this is also included for final use. So it is the same table we had already used 2 times, but I use here this one because I want to show you the last market in about some minutes what figures I have used here to make the computation which I show you now. Interrelation between final demand, you know, the second quadrant of the table, and production, the last column. You know that various categories go to make up final demand or final use, and their importance is different for each production sector. Some sectors are more delivering for private consumption, otherwise others are more producing for the foreign market, for exports. So for each sector you have the specific output situation. Industries are directly and or indirectly dependent on final demand categories. So far we know from our output coefficients only that industry are directly dependent on final demand categories. According to our approach of the inverse coefficient, we have extended our directly dependence by also the indirectly dependence. And the total direct and indirect importance of the various final demand categories for the individual branches, for the individual industry can be calculated with the above mentioned Leontief inverse matrix in the following way. You see the same formula as a Leontief model. The only difference is the following. Here the X is with big letters and the Y also with big letters. Because if we have the small X and the little Y, we would have already here the formula for the whole Leontief model. We are now want to make a so-called diagnosis because we keep inside our input-output table for Mongolia 2010. We do not combine it with exogenous data. So we say here instead of I minus A Leontief inverse C, and we multiply C with the Y. Why we can multiply? I do not know if you know a little bit about the matrix algebra. We can only multiply if the first matrix, that is in this case is C, has the same number of columns as the next matrix has the same number of rows. Because you make always a multiplication row by column sum up. Row by column sum up. So if you have the matrix, for example, 30 by 20, and you want to multiply it with the matrix 30 by 30, it doesn't work. Because you have not the same number of columns in the first matrix as you need the number of rows in the second. So the resultant matrix X shows you the industrial production directly and indirectly necessary to satisfy the final demand categories Y. In other words, it indicates the importance of each category of final demand for the production of each industry. In the comparison of the total dependency ratio with the corresponding output coefficients we have seen, it reveals whether the individual final demand dependency is accounted for primarily by final production or by intermediate production. This is our result. What we have done. We have taken the inverse matrix. I think we have seen the inverse matrix before, and we have the matrix Y. The matrix Y is our final demand matrix. This one. This is a matrix with 20 rows and 3 columns. It will be multiplied with an inverse with 20 rows and 20 columns, as we have seen in the other paper before. I think the procedure is as we tried to explain to you. You take from the inverse the first row, you multiply the first row of the inverse with a column of final private consumption. You make the same with the second row of the inverse, and you multiply it with this one. And that will be done 20 times, and you get figures for this column which are higher than the basic data for private consumption. The same will be done. You take again the inverse row 1, multiply with column 2. You take the inverse row 2, row 1, row 2, with the same one up to row 20, with this one and the same with export. And what you receive, you must receive the table that has 20 rows and 3 columns, and we will see whether it works. You see, we have a resulting matrix with 3 columns, 20 rows, and the overall total. This calculation brings us the total industrial production, the total attributed to final demand categories. Look please at first to the last column of this calculation. Look, for example, to the figures for agriculture. I think we have had this figure today very often, 1,746,000. Take, I think, the last one, 103.8, or take also again for manufacturing, 2201. Let's go back to the original input-output table. So we have the same data. There you see for agriculture, there you see for other activities, and there you see also for manufacturing. What happens? How the same data can appear in 2 different calculations, in the basic IoT and in the calculation of our final demand multiplied with the inverse. Yeah, what has happened? If you look to this basic table, we know here these are all intermediate outputs. They are needed to produce finally the final use output. So these goods are needed as intermediate goods, and they are reflected, as we have learned, in the inverse matrix. The inverse matrix only shows the coefficients. Coefficients are derived from the direct input coefficients. We use the input-output model, we make the inverse. So in the inverse, all these interconnections, which are all presented in our basic input-output table, are transformed to coefficients, to inverse coefficients, and these inverse coefficients will be multiplied with the original direct final demand or final use. If here in the inverse all the intermediate transactions are included, and I multiply this inverse by the final use, I must automatically arrive at the same total output which is here in my basic table, because you see intermediate plus final comes up with the total. What has been done? This whole part of production processes has been transformed, has been changed, has been brought to final demand. So all the intermediate inputs have been allocated to final demand, and for that reason all these data are now allocated to this one, and for that reason we arrive now in our computation at the same last column. Here, our 21 to 23, these data are composed by the intermediates, and the intermediates are shown here inside the final data. So I believe it is again the first computation where they are using the inverse, making a diagnostic approach. You multiply the inverse with the final use and you get the total industrial production. The total industrial production is this one, because you can also say total output, attributed to final demand categories in Mongolia 2010. So these all together build up total output, and in the basic table, these data are lower. Let's look. Here we have agriculture to final consumption expenditure 878. What we have in our basic table, it must be lower. We have only we have 8 at the moment. Here we have only 300. Here we have 878. In our basic table we have only 369, 740. So there is a difference. The direct final use, the direct final demand, final consumption from agriculture has a value of 369. The total, what is needed from agriculture to satisfy also the final consumption of other sectors will be 878. So these figures are always higher because all the intermediate outputs are attributed to the final demand. You will just see in some minutes what sectors are included in this additional higher final demand. Oh, there's also a small animal that wants to look for them. So I think you see the agriculture is higher. Here, manufacturing. Manufacturing in our basic IoT table delivers to final use is 1063. 1063. What is the amount if you take into account also the indirect flows? It is 1320. So you see already the difference. This is the total. You subtract the direct, and as difference you get the indirect contribution of manufacturing for final private consumption. It does not mean that the manufacturing is only delivering to this cell. It means that manufacturing has also to produce for other sectors which are contributing to final consumption expenditure. It is the same approach what we have tried to understand from our inverse. But in the inverse I told you, all is only referring to one unit, one additional unit. Now we substitute the one additional unit by our original input-output table. Instead of one for this sector, instead of one for this sector, we have now the absolute values for private final consumption. The same we have for capital formation, and the same we have for export. And instead of multiplying it with only one, as in our inverse, we multiply it here with the absolute figures, and we get the higher amount, the higher volume. It means what is needed from all the 20 sectors to satisfy the direct final demand for private households. So I think it's the same as in the inverse, but it is levied up to another level according to the final demand thing. Now I think it might be easier for you to understand because now we explain how it happens. The calculation just presented determines total direct and indirect industrial production or total output attributed to final demand categories. But it does not indicate the links which induce the indirect dependency of a specific industry. Why agriculture must produce more goods than the direct demand for their own products. And for that we are doing so-called branch-specific market analysis. To make branch-specific market analysis, we take the row relating to the industry under review, that means again row I, 1 to up to 20, out of the inverse matrix, and we formulate it as diagonal matrix. And we combine it again with the same matrix of final demands, category Y. Here you see X, Y explains now, I think before we had only the total formula. Here, it's only X, we have only I minus A, the inverse, and we have Y. What we have now, we have Xi, one row, we have D also for I, this D means the diagonal matrix, and we have Y. So we have CDI multiplied with Y. The matrix Xi shows the output of goods and services to final demand which induces the production of industry I. That means the matrix now, which we can derive for agriculture, shows us the output of agriculture to final demand, which induce the production of agriculture totally. In other words, it indicates for industry I the dependency of total output on final demand categories and their contributing industry. Let's now take from our inverse matrix from the last lecture. We take the first row. I believe I have to wait. Let's see for what I have to. Yeah. We take the first row from the inverse matrix. We write it as diagonal matrix. We have a 20 by 20 matrix. Only in the diagonal are elements, all the other are 0. And we multiply it with our final demand and we get this result. So I think the title is branch-specific market analysis between final demand and production for agriculture. So what we can see the dependency of total output of agriculture on final demand categories and their contributing industries. What happens? Look for this result, what we have here totals. So you see that I think the market analysis for agriculture, the total output of agriculture to satisfy final consumption expenditure is 878. I think for gross capital formation 518, for export 349, and our total we know it's 1,702. Let us go back to our first calculation which we have done. What is that? That is the first row of our calculation. 878, 518, 349, 1,702. So here, according to this market analysis, we are differing. We are distinguishing between the sectors that are using the agriculture products, which the agriculture has to contribute for satisfaction of private household demand. So I think we can make the so-called market analysis for each of the 20 sectors. We can make, I think we have the policy here done, but let's only look for a moment to the other one because I want to show you this one a little bit in detail. I hope to understand the total. That is the total output attributed by agriculture to satisfy column 21, column 22, column 23, and the total we have here again, the last one, will be the row of our other computation, not the market analysis, only for agriculture. What happens here? What we can see? What is the direct delivery of agriculture to these three final demand components? Let's go back to our basic table. Our basic table shows us 878, 518, and 349. These are the direct deliveries of agriculture to the three final demand components, and as we have seen, they are reflected in the overall total here, which I have already just mentioned. What is now the issue? What are the relevance for the individual parts? Agriculture is producing an output for the satisfaction of final consumption expenditure, for the sector transportation and storage, for the electricity sector, for water supply, for education, for public administration. So you see, all these issues are more or less all direct, all are indirect connections. Let's try to identify this figure here, 419. Let's go back to our original input-output table. There we have also a delivery of agriculture to private consumption. This figure, 369, 740. Now we have a higher figure for agriculture directly. We have now, I must go to the market analysis. We have now 419,437. If you build the difference, you see there is also for agriculture an indirect effect, as is low, because what we have learned at the beginning, between agriculture, forestry, fishing, there are also connections. So also a little bit must be produced for agriculture to satisfy the own demand of final consumption for agriculture, fishery and forestry products. So here in the first element, there is, perhaps you can write it on your slide, please to find. Write here down, make here two, make a differentiation between two figures. Please write here one figure here and one figure here. The first figure you should write, which belongs to 490, should be the figure from our basic IoT table. Please write down 369740. Write down this figure, 369740. Here, write down this here, and then please split the difference. What is 419 minus the 300, what we have just mentioned. This is a slow amount, and these two will add up to this figure. I have the computer, I have not so small. But I believe that perhaps one of you can calculate quickly the difference between 419.437 and the figure from our basic table, 300 so and so. What will be the difference? I believe around something like 40 so and so much. Who has the figure already available, please? The difference between that figure and the figure we have here just written down from the basic table, agriculture to private consumption. The professor from the university, he has calculated, but otherwise I have the feeling I get with the figure I can only explain you that the difference between this figure, 419, and the other figure from our basic table will be a small figure, and this small figure describes the indirect transactions, the indirect output of agriculture to agriculture. The other one will be the direct one, which we have written here, is the direct plus the indirect is the total. And what I want to show is all the other effects here are only indirect contribution of agriculture via the other sectors to the satisfaction of final consumption. The same as with gross capital formation and the same as with income. So this market analysis shows us what sectors are included for satisfying the demand of final consumption expenditure as they are shown in the input-output table of Mongolia. I think we have made the same for mining, the sector number 2, or we have made this one. We have multiplied the inverse as diagonal matrix from row 2 of inverse and multiplied it again by the final demand, then we get this result. This total again will be the second row of our overall estimate, of our overall estimation here. For mining and for 136,993, here's the same line, the same row as we have now disaggregated. Here see the last one, the second one here, as we have disaggregated again by the 20 segments. Here inside we have again direct and indirect, direct and indirect, direct and indirect. All the other are only indirect contributions. They are not directly from mining supported to final consumption. They are only following the way via all the other 19 production sectors. We have made another one for manufacturing. We took the row 3 of our inverse, made the same calculation, and we have it done, I think, also for wholesale. Here we took, I think, the row of the inverse number 7. We made the same. Here again we have direct and indirect, direct and indirect, direct and indirect. And if you look here to the figure, we have 8,176. Look back again to our overall compilation. So we have with wholesale, we must have here also here we have the 817, all the figures which are come up with the total, and these figures are disaggregated in our so-called market analysis. I think the problem what is the idea of doing that? The problem of doing that is that we want to show what other sectors are involved. Because from the total computation you only see the overall total, but you do not know which sectors are separately, individually involved. This is what we have done for the total dependency. If we have made the calculation totally, you can also express as percentages. You see that we have taken again our computation C multiplied by Y. This total computation, this one, here's the formula. This is the result. And if you say the total are 100%, you can show the 3 columns as percentages of the total. And that has been done in the table what I have just seen here before, because this is so-called, again, the output percentages. 50% of total production of agriculture will be handed over directly and indirectly to final consumption, 29% for gross capital formation, and 20% of agriculture will be exported. And perhaps you can remember the direct export was lower, because also agriculture is involved in exports of foods, in exports of accommodation. So I think for that reason, the total dependency must be higher than the direct export or the direct dependency. Here's another example what has been done for Brunei Darussalam. You see here the same, but they have here now 7 components or 7 categories of final demand. Again, the last column will be 100%, and what you can see from this table that I think private consumption is the main consumer directly and indirectly of coke and refined petroleum products, 63.9%, 50% from wholesale trade, 50% from telecommunication, and real estate services here from Valley, 89%. And you see also the exports here, so I think in the column before the last column, 100%. It also shows that from crude petroleum, more or less all will be exported by Brunei Darussalam, crude petroleum and also the natural gas. These are the main two exported products that are available, and that will be done by Brunei Darussalam. So I think another example is that what is showing you the impact of a 10% increase of exports of mining and quarry on production in Mongolia. You have an export of mining and quarry, and we increase the export of mining and quarry by 10%. And we want to know what effects are the indirect effects on all the other and all, including the coal sector, on all 20 sectors. And you see that these 282 historics induced another 115, so the overall effect total, direct and indirect. Here's a good example to see you have only one direct effect, but indirectly all sectors contribute less or a little bit more to the export of this mining and quarrying part, and both together show you, I think, the total export dependency or the total export effect induced only by a 10% of mining. So the same you can run in the opposite way. If you want to know what is the effect of a decrease of mining, I think if the price on the world market will go down and you cannot export so much, then you can also calculate what is the impact of a decreased export of mining and quarrying of Mongolia to the world. What other sectors are affected? What other sectors are taken from this decrease? Why? Because all the other sectors are contribute with a specific amount to the export of coal and of mining and quarry. I think two final examples. We have made also in Germany a specific study for our chemical association, and they wanted to know where are the important final demand markets of the chemical industry. And what we identified the 10 most important final demand markets for products of the chemical industry. You see, the most important are the exports. About 30.4% are exported from chemical industry, private consumption by 13.8%, government consumption, and so on and so on and so on. And not only chemical industry is involved, as you now understand, but you see also from construction down to machinery, the other sectors are also indirectly final demand markets of the chemical industry, because they also need chemical industry. Here construction, for example, for gross fixed capital formation, handicraft trades for private consumption, textile industry for private consumption. You know, a lot of textile is used, a lot of chemicals are used in the textile industry, and so on and so on. So these are the 10 most important final demand markets for chemical products. And I think the last one for today is important direct and indirect customers, user of the chemical industry in the Federal Republic of Germany. Again, the 10 direct and indirect most important user or customers, the chemical industry itself. Why? Chemical industry in Germany is disaggregated into 4 subcomponents. I think the basic chemicals, then some prefabricated chemical product, then I think some products for hospital, and I think the medicine, also then plastics. So we have a lot of intra-sectoral flows in the chemical industry, and then you see here construction needs chemical products, textile, vehicle, and so on. All in all, the 10 most important customers of chemical industry already use 85%. So this table has been compiled from a table with 56 production sectors and you see only 10 of the 56 production sectors have already consumed or used 85% of the output of every good. So what might be also of interest for you in the future? You will identify that you have not always big parts in all industry. You have a concentration on the main customer, on the main industries, and that can be shown here with our allocation via the inverse of the intermediate inputs to final demand, and that I could show you here in an abbreviated version, a little bit quicker, because I want to keep the time. Thank you for your attention, and now we have 5 o'clock and 17 minutes, and I think we just saw that I think
our small examples we had to end in our case studies yesterday, and I was requested about the 5th task. I think the 5th task is on page 3, and I believe you got already yesterday the result, but I want to show you how it is working. You see that I have written on the blackboard the 3 columns for direct exports, indirect exports, and total exports. If you had to solve this question, I believe at first you have to look at our basic table. In our basic table, 3 by 3, we have a column as part of final use, final demand, that is our direct exports. You will see the figures are 5, 60, and 45. That is in this small table here, this column for export, column number 5. I have written these 3 figures on the blackboard. Agriculture exports directly up for 5 units, and manufacturing exports directly for 60 units, and services are exported by 45 units. Then you see that, I think, indirect exports. But at first I will show the total exports, because the indirect exports will be the difference. Look for total exports. We have learned yesterday, if you have a final demand, the final use, the second quadrant, you can multiply the figures in the second part of the input-output table with the inverse. So you say C, that was our inverse, multiplied with Y. Y was our final demand, and the result of this work should be in your papers here on page 3, the first table. Agriculture, manufacturing purposes, then 2 columns, domestic demand and export. And here you have again the exports, but here we have not now the exports only that are directly exported, but also multiplied by the inverse, it will be the total exports. And the total export, I think the numbers are in the last column are 23, 120, and 75. Now we can deduct our direct export or subtract the direct exports from the total exports, and we get as difference the indirect export. And they are also explained there. I think the figures are absolutely shown. I think this will be 18, 60, and 30. What was the question of task number 3? Task number 3, I have not asked for the absolute figures. I asked, perhaps you can look to our task, I asked for the dependencies. And then here I have written in PC, that means in percentages. So I do not want to express the exports only in the absolute figures for tourists. I want to know the percentages. How we can arrive, having seen our 9 figures now as result, direct, indirect, and total, how we can arrive at the dependencies, at the percentages. In the final last column, I have written the total output. Total output is again from this first table. It is the last column. And if you divide now the individual figures for direct, for indirect, and for total by the total output, then you get the percentages that are given to you also yesterday with our results. You see a percentage of 6.25. 6.25, I think that is 5 divided by the total output, and total divided by 80 comes up with 6.25. And the same has been done with all the other 8 figures. So we transform our absolute results into percentages by only relating it to the total output, by making the shares of direct, indirect, and total exports divided by the total output. Because we have seen we have not only exports, we have also domestic demand. And the same you could do also. You are looking for something? So I think that was the idea, and I was presented yesterday about the solution. So you see, we come step by step. But at first, what we need is a multiplication inverse by final demand. Then from this result, we can take out only for exports. Then we take into account also the original table, and then automatically we get the 9 figures. And then later on we build our percentages by dividing the 9 resulting figures by the 3 total outputs of agriculture, manufacturing, and services. Okay? So I think he has asked me yesterday, but yesterday evening I said, no, we make it tomorrow morning. So I think that is one of the results. I think it was maybe the most difficult one of our solutions that we had to follow. So then I was also asked about the last presentation yesterday afternoon, and I will a little bit repeat that I have you to come into our subject today. So I think I will start with what I have mentioned yesterday. You see here again, I told you that there are many different linkages between the second quadrant, third quadrant, the first quadrant. And the main core, as we have learned, will be the first quadrant, which is our inverse matrix, the C. And what we have done yesterday afternoon as the latest one was that we looked to our input-output table. We know that in this part of the table, we have the intermediate transaction. Below are the primary inputs. Also intermediate transaction, primary input below, and to the right we have our second quadrant. In this second quadrant we have 3 columns. In the final publication of the NSO there will be 5 final demand vectors, because when I made the computation I had not the disaggregation of final consumption by private households and by government, and I have not shown separate cases in inventories. If you add this one, then you have a set of the 3 vectors here for final use. The 3 vectors for final use. Oh, yeah. I have here only 3, but I think in the final publication of the NSO there will be 5, because this will be disaggregated into private household consumption and government consumption. And here we have also a disaggregation by gross fixed capital formation and changes in inventories and variables. So it is the same. I think you can multiply the inverse C with 3 vectors, with 5 vectors. It's not the problem. What I already mentioned yesterday, the problem is only that the number of columns in your inverse should be the same as the number of rows in the other matrix. Not working? No. Because it is not working? Then I stay here, and then as yesterday I see it, because the people have already heard it yesterday, so it's only a repetition. It will be not so important. I can understand the translating lady, but I will try to keep here with a microphone, and I do not like the other one, because then I have 2, and it's not my way. Otherwise, I never use a microphone in a big university hall. Okay, you have understood me? Fine. Okay, what we have learned yesterday, that was an important issue. we have used the first formula to make the compilation. Compilation is what I was asked this morning. We are using the inverse matrix. The inverse matrix is this one. We defined it by C, and we took our final demand vectors. We had 3 now, and we multiplied these both matrices, and we got the result. And the result, you can remember yesterday, was this one. We had now a matrix with 20 rows, with 3 columns. And what was the most important issue, what we have raised? We have seen that the total attributed production was the same as the total output of our 20 production sectors in our basic table. And we learned yesterday why it is working this way. Because we transformed, or we brought together intermediate transactions and the final use. We took all the intermediate data and transformed them to the final use. And for that reason, we had the possibility to show in the last column the same total as we have in our basic table. Because what I have tried to explain to you yesterday, the inverse matrix is nothing else than only the coefficient matrix for the first part of our input-output table using the input-output model. The difference between the input-output model and our basic table are the including of indirect transactions, interlinkages, indirect interlinkages. And then what we have done also yesterday, we have then asked, okay, it's very interesting to see here how much has been contributed by agriculture to final consumption. Not only the data from our basic table, but also all the indirect flows that goes from agriculture to food to accommodation. And these are all products that has to be supplied by agriculture. Then we want to know what sectors are the consumer or the user of these intermediate goods. And then we made the so-called market analysis. And the market analysis was only that difference. If you look to the formula again, we have again the same inverse. But what is the difference? We are looking only for specific rows of the inverse, and we have written these rows of the inverse as diagonal matrix. And then the T means diagonal, and we multiplied this row I from the inverse, written as diagonal, with the same final demand vectors which we had before. And then we could identify, here we have now information and data, and we see here that in the final row of this result, these data, as we had seen yesterday, are fully compatible with the first row of our overall compilation, with this row. So we have seen yesterday we are able to make 20 so-called market analysis. For each of the 20 sectors I can make a market analysis by using the inverse, the row of the inverse from the table. And making this multiplication, I can arrive at the data that show me, to whom the agriculture has handed over the intermediate goods. And we had seen yesterday that all other sectors are involved, but only from the total in our other calculation we could not see who was involved. But according to the so-called market analysis, we could show the dependency of total output of agriculture and their contributing industry. That is here the important point, their contributing industry. So the other industry also use the goods of agriculture. And for that reason we have yesterday seen that we have made 4 market analyses. We took the row for mining, we took the row for manufacturing, and we took the row for wholesale, and we always multiplied these diagonal matrices with these coefficients by the same final demand. If you would do 20 market analysis, you would come automatically to the same what we have done at the beginning for all together. Because this one is only a further distinction, a further separation of our total flows. Now we go into detail and want to know who was involved. So that is the main, if you are calculating the dependency on the output side with the final demand vector. I have just thought about an idea that might help you in the future. I go back to our graph. Please write down on your slide copy, which you have, with your pencil. Be so kind and write down in this graph. So this part, which is here, please write here behind two different formulas. Right behind between final demand and production. The first formula you should write there, because then you know later on what has been done in this area. Write down this formula. X I minus A as inverse multiplied by Y. These on the graph you have in your piled copy. Write down behind, I think the first one, here. Because what we have done yesterday, it was this interlinkage, this linkages between production was here, final demand was here, and the inverse was here. So I think write here down the formula X equals inverse multiplied by final demand. I cannot write it on this, but I don't want to, because I think you only have to repeat the formula, not in the slide in the other one, but repeat it here, because then at the end today we will have formula for all these 5 different parts. And I thought yesterday evening that might be the best idea for you, and later on if you want to repeat what has been connected with what. So I think make it easier for yourself, please, what I have told already, write here down the formula behind X equals inverse multiplied by Y. This formula we have just mentioned before. This one. And also, in addition, write down the formula for the market analysis. And the other formula is this one. Now also write behind what we have just mentioned the formula Xi inverse as diagonal for I multiplied by Y. And then you have put together all what you need for making the link between final demand Y, inverse C, and then the same disaggregated by individual 20 branches. That means the so-called market analysis. You got it? I hope that you awake and that you can see it is not for me. It's only for you to help you in the future to understand better here all your material you have got in the Mongolian language. The two formulas should be also added to that what we have shown as a graph. And the interlinkages, as we have seen, between final use or final demand, and we know final demand will be our Y, intermediates will be our C, and that can be in this place. You can write here the first formula X, and the other one will be X with, I think, with D, I think, as I, for the individual market analysis, and here the first formula, and here the second formula should be seen in your graph, or I think what we had this one. Now, we are leaving these linkages, and with our next paper, we are going to a linkage between final primary input and production. There at the end we will also have two formulas. Here we have then also at the end two formulas. But we started now with the first one. I hope you have all written the two formulas with this one. Now we go to the next paper. And the next paper will be dealing with the problem of the combination or linkage not between final use and inverse, but between primary input